Let's begin the Chapter 4, Section 1 lecture notes. And Chapter 4 deals with energy. In Section 1, we're going to learn the nature of energy. And in Section 2, conservation of energy. What is energy? Wherever you are sitting as you read this, changes are taking place. Light bulbs are heating the air around them. The wind might be rustling leaves, or sunlight might be glaring off a nearby window. Every change that occurs, large or small, involves energy. When something is able to change its environment or itself, it has energy. Energy, by the definition, is the ability to cause change. Anything that causes change must have energy. You use energy to arrange your hair to look the way you want it to. You also use energy when you walk down the halls of your school between classes or eat your lunch. Energy has several different forms, and the forms are electrical, chemical, radiant, and thermal. Is the chemical energy stored in food the same as the energy that comes from the sun or the energy stored in gasoline? Radiant energy from the sun travels a vast distance through space to Earth, warming the planet and providing energy that enables green plants to grow. An analogy or a story about energy goes, if you have $100, you could store it in a variety of forms: cash in your wallet, a bank account, traveler's checks, gold or silver coins. You could transfer that money to different forms. You could deposit your cash into a bank account or trade the cash for gold. Regardless of its form, money is money. The same is true for energy. Energy from the sun that warms you and energy from the food that you eat are only different forms of the same thing. An object in motion does have energy. Kinetic energy is the energy a moving object has because of its motion. Kinetic energy of a moving object depends on the object's mass and its speed. Kinetic energy, and it's measured in joules, equals mass, and that should be 1/2 mass. Again, these guys that write these books. Mass in kilograms times time in meters per second, and that's squared. And this formula looks like KE, kinetic energy, equals 1/2 the mass times the velocity squared. The SI unit of energy is the joule, and again, a good test question, abbreviated as J. An example of kinetic energy goes if you dropped a softball from a height of about 1/2 meter, you would have a kinetic energy of about 1 joule before it hit the floor. Even motionless objects can have energy. This energy is stored in the object. A hanging apple in a tree has stored energy. Stored energy due to position is called potential energy. So these apples hanging in this tree have potential energy. And I like to use the statement or the analogy that these apples have the potential to fall. If the apple stays in the tree, it'll keep the stored energy due to its height above the ground. If it falls, that stored energy of position is converted or changed to energy of motion, which is kinetic energy. Another form of potential energy is elastic potential energy. If you stretch a rubber band and let it go, it sails across the room. As it flies through the air, it has kinetic energy because it's moving or due to its motion. Where did this kinetic energy come from? It came from the elastic potential energy. The stretched rubber band had energy stored as elastic potential energy. Elastic potential energy is energy stored by something that can stretch or compress, such as a rubber band or spring. Chemical potential energy. Gasoline stores energy in the same way as food stores energy in the chemical bonds between the atoms. Energy stored in chemical bonds is chemical potential energy. Energy is stored in the bonds that hold the carbon and hydrogen atoms together and is released when the gas is burned. And this illustration illustrates natural gas plus oxygen. When it's burned, it produces carbon dioxide and water. In this chemical reaction, chemical potential energy is released. Gravitational potential energy. Anything that can fall has stored energy called gravitational potential energy. Gravitational potential energy is energy stored by objects due to their position above Earth's surface. Gravitational potential energy can be calculated from the following equation. Gravitational potential energy, again measured in joules, the J, equals mass in kilograms times the acceleration of gravity, and you saw that in the last chapter, that G in meters per second squared, times the height of an object above the Earth. Or in other words, GPE equals M times G times H. On Earth, again, the acceleration of gravity is 9.8 meters per second squared and has a symbol G. That's what this G represents. Like all forms of energy, gravitational potential energy is measured in joules. Changing gravitational potential energy. According to the equation for gravitational potential energy, the GPE of an object can be increased by increasing its height above the ground. If two objects are at the same height, then the object with a larger mass has more gravitational potential energy. And you can see that by changing the values or the numbers in the formula for solving for GPE. This concludes the lecture notes. I'll go through these questions, and your homework for section 1 is the online section review, which can be accessed via or by your My Big Campus account. Energy is the ability to cause, and the choices are change, heat, motion, or work. And the answer should be change. Energy is the ability to cause change and has several different forms. Question 2, what are the 4 different forms of energy? And they are electrical, chemical, radiant, and thermal. Question number 3, the kinetic energy of an object depends on the object's mass and speed, the object's mass, the object's speed, or the acceleration of the object. And again, use the formula for kinetic energy, KE equals 1/2 mv squared. So with this formula, helps you answer the question, and the correct answer then would be A. Kinetic energy depends on both mass and speed of the moving object. And that'll conclude the lecture notes for section 1 of chapter 4.